Good morning, class. I decided to create this video to help you out and give you a few more resources to use when processing your data. I wanted to give you all a few examples of how some of these things can be automated and some more examples on different things you might want to do to help you get what you want out of your files. So I'm in Matlab and I have 3 example walk files that I'm running for this, and this would run for a larger number of files too, but this is just a good example to get me started. In this folder I have 4 files. I have my what I'm calling peak knee angle auto, which is a modified version of auto file load, with the only thing being changed is I'm adding 3 additional scripts that I'm running inside the file loop of auto file load, right? So inside this for_j is equal to 1 to size file names, which is the number of files that have a .mat extension in the directory. I'm going to run each of these files, starting with the rfoot gate events file, and then knee angle process, and finally Excel outcomes. This first file, rfoot gate events, is going to actually calculate heel strike and toe off, although we're only going to use the heel strike values. The second file will calculate the right knee angle, and the third file will export the outcomes that we want to Excel, so that way we can run more stats or just have that to share with our group members or to format prettily to put it in our reports. So let's run through these files one by one. The first thing we have here is my rfoot gate events, and this file is designed to calculate heel strike and toe off based off of a foot velocity algorithm that's presented in the literature. I'm going to pull it up so you guys can all see that. So this is the article. This is automatic detection of gate events using kinematic data. This data was actually designed using, I think, a pediatric population. So they used normal and children with diagnosed with spastic diplegia or asymmetric spastic diplegia in barefoot walking trials. But the primary focus of this article is identifying the gait events in the normal children. And this algorithm works pretty well for adults as well, so I've used this several times as a reference. The key thing to take away from this article here is that if you look at the vertical velocity of the foot, you get a profile that looks like this, and they can identify this local minima as when the heel strike occurs. Again, you can see here this is the vertical velocity of the foot, and this bottom graph is the ground reaction force, and this local maxima is when the toe off occurs, right? So if I can find this local min and this local max, then that works. The only thing that gets a little bit confusing here is that I have 2 local minima inside this curve, and I really only want to find a local minima when the foot is close to the ground. So if you look back at my code here, and this is all taken directly from the article, what we have is we've filtered the data. They used a 7 Hertz 4th order Butterworth filter. I'm actually using a 50-point width weighted moving average filter, which is pretty close. 7 Hertz cutoff is actually probably closer to 30, but when I ran it with 30, I actually got a local minima on the curve kind of around right here. And that local minima resulted in some errors in the calculations. So I increased the width of the filter to kind of smooth out and make that local minima go away, since it's not a very large deviation from the peaks, and that seemed to work fine. So I did that just to modify that algorithm and get to work a little bit better. That was a trial and error process. I didn't know what value was going to work best for that cutoff, but I just tried a couple different values and found one that worked consistently for all the trials that I wanted to process. I'm calculating the center of the foot just using this is the vertical position of the toe after it's been filtered, and the vertical position of the heel after it's been filtered. I'm taking the velocity using the gradient of the foot center position. And again, I'm multiplying times 200, so I get this in millimeters per second rather than millimeters per frame. And there is 200 frames per second, so that's the factor there. The toe off calculation, they used a window or a search window for the local maximum of 0.8 seconds, so I use that. And then the search window for the heel strike, which I'm going to use for the subsequent calculations, is 0.08 seconds. So I used the same windows that they did here, and I calculated that just by doing the frame rate, 200 Hertz times 0.8 seconds. That would give me the window size in frames as opposed to in seconds. And then this is the algorithm I'm using to look for the local maximum and the local minimum, where I'm just saying for I from half of the window length to the length of the trial minus half of the window length. So making sure I'm not addressing indexes that are outside the range of the velocity. If the current one is equal to the max over that window, then that is a toe off. And then down here, if the current one is equal to the minimum across that off the window for the heel strike, which I've redefined here, right? Then that we count that, but only if it is also where the right heel position is less than 35% of the maximum of the right heel. And again, this is pulled from this article here where it says the threshold level of the height of the heel marker set at 35% of the range of the heel heights encountered during the trial excludes the major trough of the foot velocity which occurs during the swing phase of gait. So this first trough right here gets ignored because the foot is too high, whereas the second trough where it actually hits the ground, that's the one that we want. So I tried that and I didn't have to modify that cutoff, although you may have to depending on what you're doing. And that gave me a fairly consistent heel strike. So now I have a consistent heel strike and a consistent heel strike and a consistent toe off, although again I wasn't using the toe off. And again, if I want to see what this looks like, I can uncomment this and run just this one file. And you can see here, that is my vertical velocity, and then these red crosses, that is where I'm expecting the heel strike to occur. And you can see that my plot here looks pretty similar to the plot in the reference, right? Theirs is in meters per second, mine's in millimeters per second. And see they're going from -1 to 1. I'm going from -600 to 600. So if you imagine theirs being about half being there, right? Even the magnitudes are reasonably consistent. You would expect my magnitudes to be a little bit higher because again, we're looking at an adult population, so the stride lengths are going to be longer and those kinds of things. But again, close enough that I can tell that this is at least calculating correctly. So I'm happy with that heel strike calculation, and I can move on to the next part of my code. The next part is probably the simplest part, the knee angle calculation. So again, I've got the foot gait events. Now I'm going to calculate the knee angle. The knee angle, all I'm doing is I'm calculating a thigh vector. That thigh vector goes from the greater trochanter to the lateral knee. And again, we're doing head minus tail. The shank vector is going to go from the lateral knee to the lateral ankle. Again, head minus tail. And then I'm using the dot product and inverse cosine to calculate the angle between those two vectors. So I have the inverse cosine in degrees of the dot product of the thigh and the shank in the numerator. Again, using the 2 here to specify the direction that I want to take that dot product in, because I have rows and columns, and I want to take the dot product across the columns, not across the rows, divided by the product of the magnitude of the shank and the magnitude of the thigh, which, oh look, there's an error in here, so let's fix this. So this is the magnitude of the thigh. The magnitude of the thigh and the magnitude of the shank, right? So that's going to give me my knee angle. I'm going to save that. And again, I can run this just by itself. And if I want to check and make sure that that's working, I can go into my workspace, find my knee angle vector. So I'm going to find, there's my knee angle, and I'll plot that. Probably replace my, let's get a new figure window here. Plot it again. So there's my knee angle. I can see it's repeating over time. It looks reasonable. I have a stance phase flexion and a swing phase flexion pretty distinctly shown there. So that's working. So I've got my gait events, I've got my knee angle, and then the part that I was most interested in sharing with you guys today is this Excel outcomes. And this is probably going to be relevant for the vast majority of your outcomes calculations. So in this Excel outcomes file, what I'm doing is I'm writing the information that I care about from each file to an Excel sheet just to keep it saved and to make it a little bit easier to share amongst groups and to transfer back and forth and maybe even process and do some of your reporting offline, you know, at home or whatever, right? So this first part here specifies the name of the Excel file that I want to use. And again, I'm just calling this run 2018-1128. I like erasing this or changing this every time I run it, so I'm always starting with a blank Excel file. This will these methods will add to an existing file if you have it, but that can lead to holes if you're adding to a file that already has some data there, and then some of that data doesn't get replaced, or you're trying to add to data and you think there's data there but there's not, and that can create all kinds of issues. So I just try and recreate the whole file each time, right? So I'm going to delete this from my current folder, so that way I'm starting with a new file without having to change the name. The first thing I'm going to do is I'm going to add the header to the first sheet. So what this is going to do is it's going to write to Excel the name of the file. That's going to be the file name. It's going to put the value file name. This specifies a cell array. So in one cell, I'm going to have the entire string file name on the sheet named stat sheet, and in position A1. And then in B1 on the same sheet, I'm going to have stride count. Let's put stride count. I don't want to do stride count. Let's just do stride count. And then on the cell C1, I'm going to say max knee angle. So this first sheet is going to take just the maximum knee angle, but I want the max knee angle of each stride, right? And then I'm going to use this row vector to indicate which row I'm going to write to. So these are all in row 1, but if the rest of them are going to start in row 2. And then I'm going to say for I from 1 to the length of the right heel strike minus 1. So if right heel strike has 2 values, I'll go for I is equal to 1. If it's got 3, we'll do I is equal to 1 and 2. So as long as I have at least 2 heel strikes, I have 1 stride. If I have 3 heel strikes, then I have 2 strides, and I can use both of those strides inside this process. I'm going to open up a figure window, and I'm going to use the handle 1, so I always get the same figure window when this goes through. I'm going to define the right knee angle as a function of the stride, so I'm using this right stride, and I'm doing this from the right stride index 1 to the right stride index I plus 1, right? So when I is 1, this will go from 1 to 2. If I is 2, this will go from 2 to 3, and so on and so forth. And then I'm also defining a percentage of stride using the linspace command from 0 to 1 with the same number of points as the my RHK stride vector. So however many points I have between those 2 heel strikes is going to be the length of that per stride. And I'm going to plot this, the percentage versus the knee angle. I'm going to plot it in blue because I want all of these to be the same color. If I was looking at like walk versus run, or one condition versus another condition, you might want to have some logic there to say, okay, if it's one thing, plot it as one color, if it's another, plot it as the other color, and get some prettier plots. I'm going to use hold on so I can add to the plot each time it goes through. I'm going to use the X label, so I'm going to label the X-axis as percentage of stride, the Y label as the knee flexion angle. I'm going to write to Excel in the stat sheet at position A row, right? So this is going to convert the number 2 into the character 2, right? And then add the A to it. So this will be A2 when row is 2. And then I'm actually going to use the file name from the loop to specify the name of the file as that first column. The second column is going to be the index I. So if I have multiple strides in a single file, that stride number will be listed inside the Excel sheet. And then I'm going to have the maximum value of my data from my heel strike 1 to 2 or 2 to 3 or whatever stride I'm in, right, written to the max knee angle column. Then I'm also going to create a 100-point array so I can look and see what the entire array of angles looks like in Excel. I'm going to use that using the linear interpolation command. And then I'm going to write that to a second sheet called R knee angle. Okay, so let's run all of these and see what our output looks like. So I'm going to run this whole thing, and this is not the first time I've ran this. I've actually ran this several times to go through and finish the debugging. Oh, I have my plots on. So I still have my plot on from my debugging inside my gate event. So I'm going to suppress that real quick. So let's suppress, comment that out. There we go. Comment that out. Close that, and then I'll come back here and I'll run this one more time. You see I get this little warning because it's creating the worksheets in Excel. You can ignore that because it's creating the worksheets and we want it to create the worksheets, so that's okay. So here I have my percentage of stride, right? And here I think I have 1 for each file, but let me have 2 for 1. Let's see how many files. Yeah, we just have 3 files here, so there's 3 lines. I'm getting one stride per each file. See, I have a nice repeatable line from each one, and since this is the same person walking at the same speed, it makes sense that there's not a whole lot of variance in that. And if I open up my Excel file, I'm actually going to open this outside of Matlab because I want to open it in Excel. You can see here I have one file, stride count, and my maximum knee angle. So I'm missing my additional files. So let's check and see if we have an error there in our Excel outcomes. We're saying row is equal to row plus 1, so we're indexing our row for length. So we should be able to get, oh, here, because I'm actually indexing this inside my, so I don't want to change this to 2. Every time I go through my for loop inside or outside the file, I'm going to reset that row, and really I want that row to stay as whatever it was in the last file. So I think what I'll do is I'll move this header data outside of my Excel outcomes file. And actually, let's do the whole thing. So I'll save that. I'm just going to put that into my knee angle outside the main for loop for the J. And the reason I want that outside of this main for loop because now I'm not going to be able to reset my row going forward. So let's try that. I'm going to close this. It's important you close the Excel file before you run these kind of things, because if you can't open the Excel file to write to it, you'll get an error. So I'm going to delete that again just so we have a blank file to start with. I accidentally deleted row. Row. Try it one more time. All right, so we ran. Again, I've got my plot. I've got my file here. So let's open this outside of Matlab. This is my second sheet. You can see I have the files 1, 2, 3. This is the knee angles normalized. So these should all have the same length. If I want to plot this in Excel, probably the easiest thing to do is to copy this, paste it transposed, and then I can go through and do insert. So again, there I have the same, basically the same plot as I had inside Matlab, where I can see each of the individual files. I'm getting more points than I need because this only goes to, I think there's 101 points in this array. So probably if I want this to look a little bit better, I can just shrink this out. Try and get just the data. There we go. So again, looks pretty much like what I had in Matlab. And then here's my stat sheets, and I have each file. I only had one stride from each file, but I have the maximum knee angle. And so I could use this to, copy and paste it into my stats. The nice thing about this is the more files I have, even if I had 100 files here, as long as my heel strike calculation was valid, this would work. And if it didn't work for just one file, right, and I could go back and say, okay, well, I'll fix that one file, manually pull out whatever the maximum knee angle is for that stride, or fix the heel strike times for just that one file. Say I got a miscount or there was an extra minimum somewhere that threw off my calculation, and then I don't have to do it manually for everyone, just the ones that it didn't work, right? Or maybe I have to change the conditions a little bit so that way it runs for a running trial or for whatever else I have. But again, the more you can automate out of this, the better off you'll be in terms of being able to quickly process your data once it's out. And I think it's a good thing to learn to be able to do, just kind of in general. So I hope that was helpful to you all. If you have any questions about any of these files, let me know. I'll post the files with the video up on Canvas, hopefully before class today. Thanks for watching.